Good day, everyone. Welcome to the second laboratory, which is the substituent and adulterants of cannabis sativa. We have first naming here the things that we have, or the materials that we have. We have the cutter blade, the tray basket, the push pin, the yarn, the ruler, the dropper, the safety goggles, the breaker, which is include the saline solution, the petri dish, which is the unknown sample, the Erlin Mayer flask have diluted ACL 50 ml, the forceps, the styrofoam itself, the glass. We have the bitter gourd leaf, the papaya leaf, the squash leaf, the pomela, camphor leaf or gabon leaf, the eggplant leaf. Now we are conducting the microscopic test of the specimen bitter gourd leaf. We have first naming those parts of this specimen. We have this one, or the upper side of the specimen. It's called the tip, and this one, or the side, or it's called the margin. And this inner, or the center of the specimen, is called the midrib. And next we have this one, or called the vein. And this one, this two, is called the leaf base, the leaf base, or the left side of the specimen. This one, the bottom part of the specimen, is called the petiole, this one. And this one, this two, is called the vignules.
Now this is the abaxial part of the squash leaf.
Okay, let's do a microscopic test to the gabon leaf. This is the adaxial side, or the front side. First, you have to determine the tip, which is the very top of the leaf. You have the margin, which is right at the, almost at the top and at the side. And the vein, which is the last thing is vein looking thing in the leaf. And the leaf blade, which is this one. And menus right here. The midrib, which is at the middle of the leaf. This one. The leaf base. Leaf base, which is right at the bottom and the side of the leaf. Now let's look at the abaxial side of the gabon leaf. It's basically the same, nothing has changed.
And the third specimen, we have here the papaya leaf, the adaxial part of this specimen. We have the upper part of this papaya leaf. We have the midrib, and the upper top of the midrib, we have find the tip. And on the side, on the right, and the left side, we have here the margin. And the lower of the margin, we have this, the vein. And now we have the inner, or the center part of the specimen. It's called the base. And the lower part of the base, we have find the petiole. And this, the right side, we have the dorsal surface. And the upper part of the dorsal surface, we can find the ventral surface. Now, we proceed to the abaxial part of this specimen. As we can see, this is the back portion of this specimen. And as we've noticed, this as the same part of the adaxial, we have the same parts. So,
This is the microscopic test of the squash leaf. Let's look at the adaxial side. First, we found the tip, which is here, the midrib, the ventral surface, the dorsal surface, the petiole, the leaf base, main, margin.
We have here the last specimen that we have. We have the eggplant leaf, the adductional part. We have the different part of this specimen. We have the upper portion, we have the apex or the apex. We have the lower of the apex, which we can find the midrib, and the right side we can find the rental surface. The lower part we can find the dorsal surface, and the left part we can find the margin or the side of the specimen, and the part of the lower part of this margin we can see the vein, and this one the center portion of the specimen we can find the base, this one, and this one we can find the petiole. At this juncture, we have now identified the different structure and different appearance of this specimen that we have. First, we have the papaya leaf. This one. Papaya leaf or leaf type, it's palmately compound, and the ventilation cross venulate, and the margin is entire, and the color has green and a rough smoothness of its part. And
The next specimen is we have bitter gourd leaf. Bitter gourd leaf has a leaf type of palmate compound and has a ventilation of gross venulate and has a margin of spenny. Had a light green and have hairs on color and smoothness.
the third one is the squash leaf. Have a leaf type of palmately compound, and ventilation is a palmate, and margin has a clinate, and a color and a smoothness is a green. It's a light green, and have a smooth part of this, some part of this specimen. The fourth one is the eggplant. Eggplant has a leaf type of a palmate compound, has a ventilation of dichotomous ventilation, and the margin is a denatulate ventilation, and the color and the smoothness is light green, and has a raw particle of this, or part of this specimen. And the fifth one, we have the Plumea camphor leaf, or known as the Gabon leaf. Gabon leaf has a leaf type of a simple, and has a ventilation of reticulate, and has a margin of a simulate, and has a light green, and has a hair of some part of this specimen. The sizing of this specimen is, first one, we have the squash leaf. Squash leaf has a length of 17 cm and a width of a 16 cm. And the next one is the Plumea camphor leaf, or known as the Gabon leaf, has a length of 5.5 cm and width is 18 cm. We have the bitter gourd leaf. The bitter gourd leaf has a length of 12 cm and width is 11 cm. And the fourth one, we have the eggplant. The eggplant has a length of 13 cm and has a width of 10 cm. And the last one, we have the papaya leaf.
Papaya leaf has a length of 16 cm and a width of 15 cm.
Proceeding to the microscopic test. Applying the saline chemical on the papaya leaf. Applying the diluted chemical on the papaya leaf. The gabon leaf without chemical. Applying the diluted chemical on the gabon leaf. Saline chemical on gabon leaf. Next, the squash leaf without chemical. The squash leaf with diluted chemical. Applying saline chemical on squash leaf. Next is the unknown specimen without chemical. Sample with diluted chemical. The unknown sample with saline chemical.
In conclusion, this forensic laboratory activity demonstrates that distinguishing cannabis from its adulterant substituents relies on systematic analysis of leaf morphology and microscopic structure. The process provides objective, evidence-based identification critical for investigative and legal application, upholding the principle that evidence cannot lie.